Okay, section 5.5, it says steps to finding rational zeros of a function. List the possible rational zeros. Narrow down your possible rational zeros using the graphing calculator. Test the possible rational zeros using synthetic division. Factor the polynomial and solve. Use the quadratic formula. Continue to test more possible zeros using synthetic division. This is just something I kind of borrowed. And then solve it. But that's kind of more or less what I want you to do. Okay, it says use the rational zeros theorem to find all the real zeros of the polynomial function. Use the zeros to factor out over the real numbers. Well, theorem is basically you take all the factors of 22, which would be 1, 2, 11, and 22. Those are the only numbers that go into 22. And you also take the factors of the lead coefficient. Well, here it's only 1. So you put the factors of 22 over the factors of 1, and for both the plus and the minuses. So all of your rational zeros will come from this list right here. And you could sit here and, I mean, that's 8 zeros and go through every one of them and see if you can find one. Well, that's kind of the archaic way, so we cheat just a little bit now. I'm going to stick it in a calculator and I'm going to find one of the zeros. Here is a zero right here, -1, or you could have started with 2, either one. I'm going to use the -1. So really you're using the factor x plus 1. You're changing the sign to a -1. The zero and the factor have a sign change. So I use synthetic division and notice I come up with 0. So that means it went evenly. So what is left right here could be written as x squared plus 9x minus 22. At that point, I try to factor if I can. Factors of x squared, factors of 22 that have a difference of 9, 11 and -2. When you solve those, you get -11 and +2. So all the real zeros were this -1 here, the -11 and 2. And then you can take those and write them into factors. X, change the sign 1. X, change the sign 11. X, change the sign -2. And that is the function written in factored form.